Once again, this is the ICE problem. I would like you to pause this video and attempt this problem on your own, and then check your answer or check your work to see if you got it right. The problem is solve x cubed plus 8 equals 0, and I'm giving you a hint. Try to factor x cubed plus 8. To do so, you will need to use one of the formulas from the last chapter, R.4, where we reviewed factoring polynomials. This would be a special case because we have x cubed plus 8. It's a binomial. It's an expression that has two terms. It could be difference of squares, difference of cubes, or sum of cubes. The first step I would do is rewrite it so we can identify which one is our case. And just so you know, this looks like it's a sum of cubes. This is the formula for the sum of cubes. In this case, we have x cubed plus 2 cubed equals 0. After I substitute and use my equation for the sum of cubes, I have x plus 2 times x squared minus 2x plus 4. 2 squared is 4. And then this factor I can already solve for x. I can already say set x plus 2 equal to 0 and solve for it. Minus 2, or subtract 2 on both sides. And I have x is equal to negative 2. That's one of my possible solutions. For the second factor, x squared minus 2x plus 4, if I set it equal to 0, it would be easy to solve using the quadratic equation, the quadratic formula. My a is 1, my v is negative 2, my c is negative 4. X equals to negative b plus or minus the square root b squared minus 4ac all over 2a. After I substitute, I have negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 4. Everything over 2 times 1, which is just 2. After simplifying everything, I got x is equal to 2 plus or minus the square root of negative 12 divided by 2, which if you notice, I have my radicand or my discriminant being negative. I'm going to end up with non-real complex solutions, and I need to write my answer with the I. Because of this, I will rewrite my answer as, or my solution for x squared minus 2x plus 4, x equals to 2 plus or minus I square root of 12 divided by 2. And I know it's concepts on top of concepts and procedures on top of procedures, but the square root of 12 we can simplify. The square root of 12 is the square root of 4 times 3, which is the square root of 4 times the square root of 3, and the square root of 4 is 2. 2 square root of 3. I'm going to substitute this 2 square root of 3 in my square root of 12. And let me continue in a different slide. I'm going to erase all this quadratic formula part that I did over here. Now, this will be, let me make a start over here. This will be 2 plus or minus I, 2 square root of 3, divided by 2. And just like we did on the previous example, if we rewrite both individually over 2, it's easier to see that I can simplify. 2 divided by 2 is 1, so I have 1 plus or minus I. 2 divided by 2 is again 1, and I just keep the square root of 3. And then I combine all my solutions. My solution set would be -2 and 1 plus I squared root of 3. You can write them combined like this, or you can write down a solution set. It's up to you, however you want to write down your answer. Here are the both possibilities, -2, like the both possibilities of writing down your solution. The x equals, or the set notation, -2 and 1 plus I squared root of 3 and 1 minus I square root of 3.